Hi, my name is Keith Hoover, president of Black Swan Textiles. In this session, we'll talk about LEDSimulator as a tool that enables color inspiration and replication. Before we get started, just to give you some idea of my background, these are some of the brands that I've worked for to implement digital color processes. We went from kind of a chaotic approach to color to a managed approach based on color data. I also am a member of AATCC, an organization that supports color in the industry, and an ARM, Advanced Robotics for Manufacturing, an organization that is enabling robotic manufacturing of apparel. In this session, we'll talk about the importance of color, one of the reasons we're here, but we'll also talk about color versus total appearance, a distinction that's important. We'll cover the three phases of color: exploration, specification, and production, and then we'll wrap up with a conclusion and discussion. Color is the most important thing in the world. It's the first thing that the customer sees in a retail environment. Whether or not they end up buying a product, they're given an impression of that brand by the appearance of color on the products in the selling environment. That's why organizations spend a lot of time doing trend research on color, trying to figure out the colors that will appeal to their customers in the next year when the products hit the market. And as such, they focus on basically the simple appearance of the color. And it's well known in the industry how we deal with color. In one sense, we need to be aware of the setting that the color is viewed in, because two colors that match each other in daylight may not match each other in the store situation under the different lights. So the light source is known to be a contributor to how we perceive color appearance. Additionally, I think we all know that we don't see color quite the same. We all recognize red, green, yellow, blue, that is, unless we're colorblind. But there are models and a lot of research that shows that people see colors in slightly different ways. So we need to standardize what that observer is, that the person who's actually seeing the color, how that person experiences it. Total appearance is something different. It deals with the object itself, the actual physical product. In this case, we're talking about a heavy gauge knit sweater. There are two components. There's the color appearance, and then there's the textural appearance, and they differ. It's more obvious in heavily textured substrates like this. We can clearly see that bright yellow of the yarn itself, but then there's the shadow and the grays that enter into our perception based on that texture. So we understand that if we were to pull the yarn out of that sweater, the color of the yarn itself is this light bright yellow. And we also understand that the ribs and the shadows created by texture tend to dull down that color. Instruments that measure color tend to merge those two. They tend to just squish them together and say, well, that color is actually dull yellow, not bright yellow. But that's not how we see, because they're not capable of separating color as an attribute and appearance as an attribute. And that's one of the things that we'll be discussing today as an important feature: the ability to distinguish the impact of color and the impact of appearance or texture. So as we go into product development for a new season, there are three phases that involve color. The first is exploration, finding that perfect color. That's the role of a designer, to use their talent, their inspiration, their insight into finding that perfect product attribute. Once those colors are selected, then it's a matter of specification, either in a CAD system so that the croquis can be built, the line plans can be built, the 3D assets can be rendered in the software, or sending those colors out to the mills to dye fabric that match those specifications. And finally, we get into production when the mills are actually producing lots and lots of fabric that goes into the garment, not just mere lab dips. So let's take an in-depth look at color exploration. Let's kind of take a look at what's happening in the industry today for color exploration and what are some of the opportunities that could improve it. First, why is this shirt blue? A simple question. That's the color of that shirt is blue, but why? Well, a dyer might describe the process of adding dyes to a bath and those dyes reacting with the fiber so that the chromophore actually bonds to the fiber instead of the water. And there are all kinds of models behind this with Kobelka Monk and K/S and absorption and many ways to describe the model of color. But that's not why the shirt is blue. That's how the shirt is blue. That's how blue was added to the fabric. We also might consider the way the eye works. There are models for describing how the electromagnetic spectrum of light reflects off of a surface and enters the eye and is processed into signals and ultimately interpreted in the brain as a blue appearance. But there again, that's not why the shirt is blue. That's what blue is. That's a model of blueness. Frankly, the shirt is blue because the designer wanted a blue shirt. And that's an important distinction. Too often in color management, we get caught up in technical explanations and make things more complicated than it needs to be. At this phase, it's blue because that's the color it should be, according to a designer. So there's a need to focus on tools that support this, the designer's ability to select the right color. Because before there are color palettes or lab dips or garments, there's the design inspiration. And inspiration starts with the designer. It starts inside the designer's head. There's this feeling, there's this inspiration, this idea of what the product should look like. Color doesn't start with libraries or CAD software or spectral data or QTX files. It's in the designer's head. So the designer needs the right tool to find that perfect color. So how is it done today? Well, a lot of brands basically go in search of a color. They look for found objects, cuttings of fabrics, perhaps their old garments, perhaps their paint chips, perhaps they've gone to a thrift shop and bought an old garment and said, oh, that's a perfect color. And so these found objects are cut into little pieces and they're distributed. The designer keeps a set, the product developer keeps a set, sourcing office keeps a set. By the time it gets to a mill, there's this little piece of fabric that's barely big enough to see. And the mill is expected to be able to match that color. Now, the way that a mill works, it's difficult to measure a small swatch of fabric like this on a spectrophotometer. And in fact, it's very difficult to actually sense what that color is because the swatch is so small and it's surrounded by this white paper. It's tough to get a real feel for what that color is. And then you see examples like on the right of a swatch of fabric taped to a printed piece of paper with the same color. Now, I always wondered, why would you do that? If you can print the color, why do you need to stick the fabric on it? Well, it's because color printing is not that accurate either. So there's this double effort to print the color and then stick a swatch on top of it. Not the most efficient process. There are more commercial color reference sets that are sold to design studios. They're not the most inspirational products, not because they're ugly colors, but because they're limited in nature. A good color reference set may contain between 2,000 and 5,000 colors, but it's estimated that there are about 2 million distinctively perceivable colors that can be created on fabric. So if you have a set of 4,000 colors, that represents 0.2% of all the available colors. So even though 2,000 sounds like a lot, it's never enough. But the bigger problem with commercially available color reference sets is psychological. When a designer starts a season, their challenge is to create something new, something that hasn't been done before. And yet, their color references were chosen by someone else. So emotionally, it's tough in a lot of brands. And I've heard this argument over and over again. Why should I use those colors? They're not mine. They're not original. They're not inspired. Additionally, color reference sets by design don't have texture because they're intended to portray the color, not the total appearance. So although they do a good job of defining blue, red, yellow, green, whatever color they're supposed to be, they're not a good tool for evaluating total appearance or seeing what that color would look like in a texture. And that is a major concern for designers because they understand the impact that texture has on color. But they're choosing colors at the beginning of the season before products are actually selected. There's also been a trend recently where companies are introducing fiber-specific color reference sets, like colors on polyester or colors on nylon. Well, that may sound nice, but frankly, it's a waste of time and money. The color itself is defined by the data behind it. In other words, how that color can be matched on polyester, on cotton, on wool. And if there are distinctions between a color on polyester and on wool, part of it has to do with the dyes used to create it, but actually much more of it has to do with the surface texture, whether it is a smooth fabric or a coarse fabric. So the idea that a color standard is good for polyester just isn't true. So as we progress, as we create these commercial color sets, as we enter this age of 3D and digitalization, there's been progress made on digitizing color. In other words, taking a physical swatch of color, measuring it on an instrument called a spectrophotometer, and then producing data. So we take something that's subjective, some type of red, and we digitize it so that we have a set of data that makes it a very definite, objective definition. That's great. But what's missing from this sequence? We've got the physical swatch, we have the instrument, we have the numbers. Who chose the color? It's back to the question is why the shirt is blue. Who chose that color? We have to remember the importance, the primacy of the designer's involvement in this process. They're the one that adds the finishing touch to that design, that makes it come alive, that makes it valuable. So we're here today to talk about LEDSimulator, and its digital interface is called Colorway. LEDSimulator is able to use digital aspects of color, map them and tie them into physical attributes of color so that the designer can see the total experience of total appearance. It starts with a simple process of selecting color. At a high level, the designer chooses basically the hue that they want to see. Red, green, yellow, blue, orange, purple, turquoise, whatever. Just at a very coarse level. So let's say the designer wants a yellow. Then a page of pop-ups occurs, variations of that yellow, yellows that are duller, yellows that are lighter, darker, whatever. So the designer then chooses the closest version on that page of what they want, and it goes to a color picker interface, which all designers who are using CAD software are familiar with. This allows a designer to make those tweaks, those small adjustments to get the color just right. But wait, there's more. It's not just color on a computer screen. At this point, we have the ability to introduce that signal of color from the computer screen into LEDSimulator, the product. And here's how it works. You'll notice that this device looks like a light box. It has standardized lighting inside of it. But in addition, there's a square cutout in the back wall of the light box called an aperture. That aperture, that cutout, can be different sizes so that you are able to increase or decrease the view. So what else is going on in this unit? Well, let's take a look at the back. On the back of this light box, there are two panels that have LED light sources in them, thus LEDSimulator. And those light panels illuminate a backdrop that sits in back of the unit itself. So on that backdrop, we hang a piece of fabric, a piece of textured fabric. In this case, it's a piece of terry cloth, a terry towel. So we want to see how color will look on this piece of textured fabric. So the designer then, working in the software, goes through the sequence of choosing a hue and then choosing a variation and then tweaking it so they get the perfect blue shade. They click a button, the signal goes to the booth, it projects the light onto the fabric, and the designer sees that color, that blue color, on top of the material. And as you can see inside the light booth, that aperture in the back, that's how they're seeing that swatch. This isn't a computer screen. This is merely an illuminated piece of fabric. If you were going to look at that fabric in the light box itself, it would be lit with white light to a certain illuminance level. Instead, LEDSimulator lights that fabric with a very, very precise version of a shade that corresponds to the color that was selected in the computer interface in colorway. In addition to seeing the total appearance, you can also isolate the pure color appearance, factoring out the contribution of texture. This is the pure color that is applied to the fabric. But when they're grouped together, again, we see the total appearance. So in essence, that is the selection process the designer would go through to use said LEDSimulator in color exploration. What this gives, in addition to color selection, it gives creative power to the designer. If they can imagine a color, then they can create it in the software. They can make it perfect. They can tweak it to their heart's content by themselves without initiating lab dips. And they can see what that color looks like on any fabric that they have access to. So they can sample that color on cotton jersey. They can sample it on piqué. They can sample it on fleece, on corduroy, to see what the impact is and make adjustments to the color that account for the impact of texture. Additionally, they can match existing colors. Let's say they found the perfect swatch and they want to visualize that color on different substrates. They go through a similar procedure in colorway to match that color. They can use data input from spectrophotometers, from other color software to get that initial color and then go through tweaking it to make it perfect. And then they can sample that color on various textures. That's the power of this tool. It's a selection tool, but it's also an aesthetic tool. So we've selected our color in exploration. Now we got to specify this through the rest of the process. Well, if we're working with traditional color swatches, be they found objects or standard color sets, one of the questions you have to ask is, can I get what I see? Can I actually get that color into my CAD software program? I have this great swatch, but how do I digitize it? And I have this great swatch, but it needs to go on a different type of fabric. So will it be possible for the mill to match that color on that fabric? And if they can match it, will the fastness that that fabric demonstrates be within my company's requirements, be it color fastness, light fastness, croc, whatever? And will that color stay the same? Will it be acceptable under different lights, or will it shift back and forth like we saw earlier in the presentation? So the first step that color specification requires is building those colors in CAD so that the designs can be created in software and printed out, and line plans can be built, and croquis, all the traditional stuff. So let's take a look at how that works today. Pantone 711, a standard color, been around for a long time. In Photoshop, there are color libraries with preloaded colors. So let's see if we can find Pantone 711 in one of these libraries in Photoshop. Well, it turns out there's a bunch of Pantone libraries. So I wonder which one Pantone 711 is in. So I do a quick search function, and I find out that there is a Pantone 711 in 6 different libraries. And when you look at the shades, there's 6 different shades. Why is that? Well, let's take a look at the names, and I think we'll get a hint as to what's going on. We have Pantone solid coated, solid uncoated, color bridge coated, color bridge uncoated, solid coated, and solid uncoated. So what this means, what the difference between a coated and an uncoated color is, if you look at the physical fan deck of Pantone, if you have a coated deck, you'll immediately see that there's a shiny surface. There's something that's been applied over the color that makes it glossy. And on uncoated swatches, there's no gloss surface. It's matte. It's flat as can be. So this was Pantone's attempt to deal with surface texture, to deal with total appearance, because there was something that wasn't the same between a coated and uncoated, and that was the appearance, that was the sheen. But the second that they took those colors and digitized them, they basically merged appearance and color into one measurement. And now you have something, you have 2 colors that don't match each other with the same name. So they have transformed a 3-dimensional object into a 2, and we've lost something in the translation. Now there's more than just coated, uncoated going on here. Pantone introduced new products along the way, and for some reason they weren't consistent in the appearance that each name specified. So there's built-in confusion from the start for Pantone 711. Now with that color, since this is software, since this is digital color, Photoshop provides LAB values. Now what an LAB value is, it's a digital definition of a color that is device independent. That means I can take that color and I can input it in Photoshop or in several other color matching software packages, and I should get the same color. So it's a standardized definition of that color. So what I'm going to do is I'm going to take the LAB values that are supplied in Photoshop, and I'm going to put them in a different system. Well, as you can see, they don't match either. I get the same variation going across the row that I see in the first row. But when I go up and down, They don't match. The LAB versions tend to be darker and brighter. There's similar consistency going across, but it's different. So then finally, since these colors are intended to be used on paper, on printing, Pantone also makes a product called TCX. That is, it's a textile cotton standard intended to be used in the textile industry as a color standard. So let's search, we can digitally search from the LAB data to find the closest available TCX color from Pantone. And this is what they look like. Now, it's not too bad. They're fairly close, but they're different. The TCXs are fairly close to the LAB versions of these colors. Not very close to the original out-of-the-box versions of the color. But digitization is meant to simplify processes. It's meant to take out subjectivity. But what we have here, we wanted one color, and we have 18. So something didn't work. Now we've passed the CAD development process, we're going into product development process, specifically color. We're sending swatches out to mills to see if they can match them. It's a long process, rather complicated and inconsistent. I've seen this at several brands, both the brands I've worked for and the brands that I've consulted with, and everybody pretty much works the same way. You have a trend group at the beginning of the season who searches the world for groups of colors that they think will be popular when these garments hit the store. And then designers work from that trend information. They build palettes out of specific colors. That information is added to a PLM system or to a spreadsheet or however the work is documented. The information is handed off to the sourcing department who works with the vendor, and then the vendor sends the information to the mill. So already, just this communication process from the beginning of the specification to the supply chain is rather cumbersome. Then the fun begins. The mills start creating lab dips to match these colors. They send them back to the vendor who sends them to sourcing, who sends them to the design group. 9 times out of 10, they're rejected. So the process starts all over again. And it keeps circling round and round and round until either the color is acceptably matched or you run out of time. What we need in this specification process is clarity. We need a single source of truth. We don't need 18 versions of one thing. We need one version of one thing. And LEDSimulator does that. It defines color at the beginning and then drives this digital workflow. It provides the right data for color specifications in any application, whether it is for the internal CAD group or for the supply chain. In essence, what you see is what you get. It's as simple as that. No more confusion, just a single source of truth. Here's how it works. Graphically, we have the LEDSimulator at the intersection of these 5 processes. We start by choosing colors for a palette. And these can be specific palettes for a subset of products, or it can be general palettes for the entire season. Then we load that. You take that color data, that digital data. We load our color software so that we have one version, one definition of that color that feeds all the developers. That allows us to produce consistent artwork for production, whether it's for graphics and screen printing or full width printing or embroideries and other assets that are added to the garments. It provides data that drives a digital lab dipping process, cutting a lot of time out of the calendar. And finally, it gives color information to the people building the e-com platforms, the digital websites, so that there can be a consistent version of color right from the source, right from the beginning, that single source of truth, so that the color is accurate on the e-commerce portal. Now, the purpose of designing a garment is to make a garment, to make garments in multiple quantities that can be sold profitably and efficiently. So let's take a look at color manufacturing. Well, when it comes to production, the designer has an idea for a color, and then the mill has an obligation to match that color. Sometimes, if the designer can't find the right color during exploration, maybe they didn't find the right found object, or maybe their color reference set didn't have the color that they wanted. Well, they'll send something out as kind of a starting point. You know, I kind of want this, but can you make it more bubblegummy, or can you make it more romantic? Well, that makes sense to a designer, believe it or not. It makes no sense to a mill. And so a mill is trying to match something with no definition. That's very difficult. That means that design is taking place in production, which is the most expensive phase of the whole process. Perhaps the designer found that perfect color, but they don't know if it's feasible. They don't know if it can be matched on a particular fabric that they want. They don't know if it can meet the fastest requirements. So they're hopeful. They're crossing their fingers and they're saying, man, I hope it turns out right. The third type of standard that everybody loves is a feasible color standard, a standard that we go into the process knowing that it's matchable on cotton, wool, polyester, nylon, whatever substrate. We know what the fastness will be. We know that it will be a non-metameric match, so it will be the same color in multiple light sources. The feasible color standard for the designer is important, and it's super important for the mill because it gives them a target that they can shoot for, and if they can match it within tolerance, that means they have succeeded. It takes all of the questions out of the process. In essence, this is what the happy path, the ideal process should look like. We'd start with color exploration using LEDSimulator to vet all available colors. And then we would convert that selection into the proper colorimetric data. That means the digital color data that feeds different processes. In essence, we've created a palette up front that we are happy with, that we are satisfied with, that these colors will be on all the products that are going into the market that season. We then, when bombs are actually built, when we start designing products and choosing fabrics, we can go back and we can vet to make sure each of those colors looks right on the particular texture of each fabric if we want. Perhaps we've done some of that vetting on generic textures during the color exploration phase. We can go back now on the critical substrates and confirm that this color is right. So that means we not only have a good color standard, but we have a color and an appearance spec set for the fabrics that are critical that can then be communicated to the mills. We get to the mill level, they use their tools to match color, confirming the final appearance in LEDSimulator, and then as production is dyed and finished, the data is uploaded to a cloud-based system so that the brand can confirm that all of production meets the expectation. The goal here is that final product looks exactly like the color inspiration that the designer found in LEDSimulator. LEDSimulator, the data coming out of LEDSimulator supports the best practices that mills follow. A lot of ingenuity, innovation, technology is in use in the dye house, so that the data coming out of LEDSimulator can support dye formulation, the recipe formulation that is traditionally used in dye houses to get the perfect color. LEDSimulator can be used as a visual way of confirming color and appearance. And the same data that comes out of LEDSimulator can be used to drive some of these digital assessment paths where visualization is taken out. Mills are very good at coming up with ways of efficiently matching colors. Some of them are, you see across the industry, some of them are proprietary to mills. But the important thing to realize here is that the data that comes out of simulator supports all three of these paths. So in conclusion, what have we learned today? First of all, getting the right color is the primary goal of a designer. It's not good enough to replicate ugly colors. You want to replicate the right color. So color is the most important product attribute. Color exploration, the ability to search for and find that perfect color, is a key phase in product development. Having the right visualization tool to find that perfect color, to discover it, super important, doesn't really exist today. This color selection is not a multiple choice test. It's a discovery. LEDSimulator is the vehicle that allows the designer to visualize what that right color should be. This drives efficiency into the product development process. And anytime you see increased efficiency in a process, you can start looking for savings. And in a session in a little while and a little later today, we'll go after those savings. We'll quantify how much a brand can expect to save, how much a mill can expect to save if the process is right. So that's LEDSimulator. That is the tool. That's the process. That's the reason. And I thank you for your time. And I look forward to discussing this further. We'll take questions. And then a little later on today, we'll talk about the financial aspects of LEDSimulator. Thanks.